Hello everyone, welcome to workbook. The question says coefficients of three consecutive terms in the expansion of 1 plus a whole raised to the power n are in the ratio 1 is to 7 is to 42. Then find n. Let's see how can we find n. First of all, given to us the expansion 1 plus a whole raised to the power n. Okay. And the first three terms are in the ratio 1 is to 7 is to 42. Let's solve this solution, and for the solution we will take the help of binomial theorem. Okay, as per binomial theorem, the general term or the r plus 1th term in the expansion of 1 plus x whole raised to the power n is tr plus 1, which is equal to ncr x to the power r. Coming to the question, let us assume the three consecutive terms be tr minus 1, tr and tr plus 1. Okay, so coefficients of these three consecutive terms will be considered as the three consecutive coefficients. Okay, so tr plus 1 for the expansion 1 plus a whole raised to the power n will be given as ncr a to the power r according to this information. Okay, accordingly tr will be equal to ncr minus 1 a to the power r minus 1, and tr minus 1 will be equal to ncr minus 2 a to the power r minus 2. So the three consecutive coefficients here are ncr minus 2, ncr minus 1 and ncr, and according to the question, these three consecutive coefficients are in the ratio 1 is to 7 is to 42. So to solve them, we have to take pairwise and solve. So in the first bit, let us take ncr minus 2 and ncr minus 1. Okay, so ncr minus 2 is to ncr minus 1 is equal to 1 is to 7. Okay, and now let me give an information to you, which is ncr equals n factorial upon r factorial into n minus r factorial. Accordingly, I will expand ncr minus 2 and ncr minus 1. Okay, so I can write that n factorial upon r minus 2 factorial into n minus r plus 2 factorial, okay, divided by ncr minus 1 will be equal to n factorial upon r minus 1 factorial into n minus r plus 1 factorial. This is equal to 1 upon 7. Okay, now this will further become, if I try to simplify this, n factorial upon r minus 2 factorial into n minus r plus 2 factorial multiplied by r minus 1 factorial into n minus r plus 1 factorial divided by n factorial. This is equal to 1 upon 7. Okay, so here we have n factorial divided by r minus 2 factorial into, I can write n minus r plus 2 factorial as n minus r plus 2 times n minus r plus 1 factorial into, we have, I can write similarly r minus 1 factorial as r minus 1 times r minus 2 factorial into we have n minus r plus 1 factorial divided by n factorial. This is equal to 1 upon 7. Okay, which indicates here we have n factorial, r minus 2 factorial and n minus r plus 1 factorial. These three terms present both in numerator and in denominator. So when these three terms will divide, this will give 1. So finally we will get r minus 1 in the numerator, and in the denominator we will get n minus r plus 2, which is equal to 1 upon 7. Now if I cross multiply, I'll get 7r minus 7 equals n minus r plus 2. Now if I want to write n in terms of r, I'll get n equals 8r minus 9. Let this be equation number 1. Okay. And now for the second bit, I will take the coefficients NCR minus 1 and NCR. Both are in the ratio 7:42. Okay. So I will write NCR minus 1 is to NCR equals 7:42. Okay. Which indicates n factorial upon r minus 1 factorial into n minus r plus 1 factorial divided by n factorial upon r factorial into n minus r factorial is equal to 7 upon 42. Okay. If I try to simplify, I'll get n factorial divided by r minus 1 factorial into n minus r plus 1 factorial multiplied by r factorial into n minus r factorial divided by n factorial is equal to 7 upon 42 can be written as 1 upon 6, because 6 times 7 equals 42, which indicates n factorial upon r minus 1 factorial into, I can write this n minus r plus 1 factorial as n minus r plus 1 times n minus r factorial into, I can write r factorial as r times r minus 1 factorial into, we have n minus r factorial divided by n factorial, which is equal to 1 upon 6. Okay. So here n factorial, r minus 1 factorial and minus r factorial, these three terms are present both in the numerator and denominator. So when they will divide, they will give 1. So finally we will have r upon n minus r plus 1 is equal to 1 upon 6. If I cross multiply, I will get 6r is equal to n minus r plus 1. And now if I try to write n in terms of r, I will get n equals 7r minus 1. Let this be equation number 2. From equation number 1, we have n equals 8r minus 9, and from equation number 2, we will have n equals 7r minus 1. So as n is the LHS in both the equations, so RHS of these two equations must be same. So 8r minus 9 must be equal to 7r minus 1. Okay, which indicates r is equal to 8. Okay, so I got r is equal to 8. Now if I put the value of r in equation number 2, I'll get n. So n will become 7 times 8 minus 1, or n is equal to 56 minus 1, which is 55. Okay, so the question had asked us to find the value of n, and here it is. Okay, so now we can conclude that the value of n is equal to 55. Hope you guys understood the explanation very well. Thank you.